All right, so today we are doing section 412, the intro to higher degree polynomials. So in other words, polynomials that don't just have like x to the first power, but maybe x to the third, x to the fifth, that type of stuff. So higher order polynomials. Now, polynomials have names, okay? So we'll name them certain things. So let me put this right here. All right, so names of polynomials. All right. Now this might look a little weird, but we're just focusing on the x term, okay? The x terms and the power. So I might write the letters in different colors. But first one, if it looks like this, let me just change the... okay, notice the x is to the first power. It doesn't have a power on it, right? So we say it's the first power. This is called a linear function. Okay, that's called a linear function. So we've been doing that like y equals mx plus b, right? That's our slope-intercept form. That's a linear function, okay? Now second one right here. So a, and then if you have, say, like x squared plus bx plus c. Notice how I didn't change the second x, okay? Because I'm only looking at the highest power, okay? So yeah, x to the first is there, but x squared catches my eye, and I see that, so x squared is basically the most important thing. This is called a quadratic function. Okay, so quadratic. All right, so quadratic function because the power is 2. Okay, third one, and I kind of have to show you, I think up to fifth power. So the next one would be ax cubed. Plus bx squared plus cx plus d. This is called a cubic function. Okay? So the first like 10 problems that you guys have to do on your homework, there's 22 problems, I think, or something like that, or 24 that you have for homework. The first 10 are going to be like this. They're going to give you an equation. They're going to say, what kind of equation is it? Okay? And then they're going to say, what's the degree? Okay? And they might ask you, like, how many terms? So, so we'll talk about that right now, but I just got to kind of give you the names for it right now. So the fourth one, this is going to be called a quartic function. So a x to the fourth plus bx cubed plus cx squared plus dx plus e. This is called a quartic. And then, like I said, they always want us to go all the way up to 5, so we're going to do one more. And again, it's important you guys keep these notes next to you when you're doing your work, because all you got to do is look for the highest power. If the highest power is a 2 on your problem, then you're going to say it's quadratic. If the highest power is a 4, you're going to say it's quartic. If the highest power is a 1 that you see on the x variables, or on the p or whatever variable they're using, you're going to call it linear. Okay? You don't have to do any work. Just tell me the name. All right? So right now I'm going to actually show you guys a homework assignment on here. I'm going to project it onto it so you guys can check it out, and it'll be pretty easy. So here's the last one. So ax to the fifth, and after that they don't really want us to go any further. So this would be bx to the fourth plus cx cubed plus dx squared plus e to the x plus f. This is called a quintic function. All right, so I'll just kind of highlight those things here. Again, these are the names of them, okay? So depending on what they ask you, what they give you, you should be able to tell them what the name of the function is. All right? So the instructions on your first 10 problems say, name each polynomial by degree and number of terms. Number of terms honestly doesn't even matter. What matters is the degree. Okay, so let me give you some examples of this. We'll do 2 of them real quick, and then we'll move on. Because like I said, this is very simple. So here's example number 1. I'm going to put name the polynomial. All right, so you guys have your notes in front of you. I'm going to kind of move the notes I put up. But name the polynomial. Here's 2 of them, okay? If I put negative 6x to the third plus 4x minus 2, and then the next one we'll do, try to make it like a trick problem here. Part B is done like that on purpose because they want to make sure that you're focusing on finding the highest power. Okay, that's called the degree. So right now we'll write that down. But the highest power is what we call the degree, and we're going to introduce that for the next little set of notes right now. But if you look at part A, what's the highest power in part A? A 3. And what kind of name does that have for the function? Cubic, right? So all I'm going to write is cubic. You can write cubic function or just cubic. It's fine. Okay? And what's the highest degree in part B? 4. So what is that called? That's a quartic, right? Quartic. So quartic. And you can put function if you want. I'll just write it down right here. But you don't need to. But there you go. So you got 10 problems like this. Is that going to be really hard to do?
No.
No, it should be really quick. Just look at your notes. Like I said, your notes are going to be the key. Okay? So, all right. Next set of examples here. First off, let's define the degree. And we've talked about this before, but I just want to put it here. The degree is the highest power in a polynomial. So that's not hard. It's not hard to do. Just look for the highest power. Okay, so whatever the highest power is, we call it the degree. So for part A, the function was of degree 3, right? That was the highest power. For part B, the function was of degree 4 because that was the highest power. Okay, now why does that matter? Well, the next definition is going to tell you a little something about what the graphs look like based on the degree. Maximum number of turns. Okay, here's a definition. So obviously a function can go up and down and up and down and up and down, right? Or maybe it just goes down, maybe it goes down then back up, okay? So there's a way that we can tell how many times a function can turn possibly. The most amount of times, the maximum number of times, okay? So the way you find the maximum number of turns of a polynomial is found like this. You're going to get your degree and you're going to subtract 1. Okay? So your degree minus 1. Okay? So I'm going to put right here max number of turns of a polynomial. So if all you have to do is get the degree and subtract 1, so 1 less than the degree, how many turns does part A have? 2, because the degree is 3. 3 minus 1 is 2. That means that that function will turn at the most 2 times. Okay, so it might go up and then turn down. That would be 1 turn. And then turn back up. That would be 2 turns. So that graph might look like this, kind of like an S shape. Okay, how many turns does B have? 3 at the most. It could have less, but at the most, it could have 3. Okay, so I'm going to do a real quick example on that. You guys have 4 of those. Those should be pretty easy. And then we'll move on to what I would say is like the more complicated part. And like I said, it's complicated, but just use your notes and it won't be that difficult. So example number 2, name the max number of turns for the polynomial. So just tell me the maximum number of turns for this polynomial. Okay, so they're going to start writing them out like normal functions, so f of x or f of y or f of whatever. So f of x equal to, let's say, negative 3x to the 6th minus 6x to the 4th minus 12x plus 4. Okay, and then for part B, we'll make it really easy here. We'll put y equal to x to the 4th minus 6x to the 5th. So we'll give you one that looks really complicated, but again, it doesn't really matter. I don't care what the function looks like. All I care about is what? What's the only thing I'm focusing on for these? The degree. Yeah, the highest power. So what's the highest power in A? 6. So how many turns does it have at the most? 5. 6 minus 1, right? So 5. That's it. What about part B? What's the maximum number of turns? Well, it's 4, right? Because the degree is 5, and 5 minus 1 is 4. So there you go. Not hard, right? So pretty easy, not a big deal. So you got 4 of those. So far we've covered 14 of the problems. Okay? Should be pretty easy. Okay? All right. Now the next part is I don't want to say the hard part, like I said, it's kind of weird. There's a lot to write down, but it's pretty easy once you see what you need to know. So it is a lot to write down, so here we go. This is called behavior of a polynomial function. Now it's defined in 2 sections. Whether or not the degree is even or if it's odd. Okay, that depends a lot on what a function looks like. If it's even, the graph looks a certain way. If it's odd, well, it doesn't look. It behaves a certain way. And if it's odd, it behaves a certain way. So there's 2 different ways. So I'm going to start off with even. So I'm going to start off with let f of x equal to, this is going to look really weird, okay, but don't get scared by it, because your problems are not going to look like this. We'll just put right here some number at the end. In other words, they're saying, look, I'm gonna give you a polynomial, okay? And the powers are gonna, there's gonna be a high power and then a lower power and then a lower power. That's what the n minus 1, n minus 2 is. Like the powers are gonna start going down. So just kind of know that that's supposed to happen. So they're saying we have a polynomial function, okay? Again, don't get scared of the way that looks like. Your problems are going to look more like part A, okay? They're not going to be all weird with weird powers, okay? They're going to look normal, but it's just a definition. So let's assume that you're given a normal polynomial function, okay? But the reason why I wrote that is because I have to state the following. If n is even. Now n is my degree. So if my highest power is even, okay? So x squared, x to the fourth, x to the sixth, x to the eighth. If that's my highest power, an even power is my highest power. All right? If n is even, and then here's the first part here. And if a is positive, actually let me do a colon here. So if n is even and the coefficient in front of it is a positive number, say 2x squared or 4x to the sixth, okay? So a positive number with an even highest power. All right, so if that's the case, it rises to the left and it rises to the right. What that means is the graph might look something like this. Now, there can be variations of it, okay? It could even look something like this. But the important thing is, on the left side it's going up, and on the very right side it's going up. Okay, you guys can see how it's going up and up, right, on both graphs. Up and up at the very ends. So this is called endpoint behavior. I can actually put that just to kind of give you more of an idea of what they're talking about. I'm going to put right here, endpoint. Okay, it's called endpoint behavior. So at the ends, what's it doing? Up and up, okay? So if A is positive, it's up and up. If A is negative, it's down and down. Okay, so let me write that down right now. And this is only if your degree is even. So if A is negative, it falls to the left and it falls to the right. In other words, the graph might look something like this. Okay, notice how the arrows are going down and down on both sides of each little graph that I drew, right? They're both going down. Okay? So that's if it's even. If it's odd, they look a little different. Okay? But again, if n is even, you have to focus on A as well, the number in front. And then based on that, you're going to tell me whether it's going up or down, that type of stuff. Okay? So let me write down if n is odd. And then we'll do some examples. So if n is odd. So in other words, it's n to the first, or sorry, x to the first power, x to the third power, x to the fifth power, seventh power, ninth power, okay? If your highest degree is an odd power, and if A is positive, it falls to the left, rises to the right. This is what I told you guys. This is going to be kind of weird, but if you have your notes, it's easy because all you got to do is ask yourself, okay, where's my degree? Degree is a power of 5. My number in front of that x value is like a positive 7. Okay, so it's a positive A with an odd power. What is it supposed to do? Falls to the left, rises to the right. Okay, that's what it does. Because these are your answers. These are the answers you guys are putting. Falls to the left, falls to the right. Falls to the left, rises to the right. Rises left, rises right. That's what you're going to be writing from. Okay? For a lot of these things. So these might look something like this. I mean, they can get more complicated, but as long as the left side is going down and the right side is going up. Okay? And we got one more of these, and then we're going to do a little bit of description without graphs, and then we'll do some stuff with graphs, and then we're done. So I know, like I said, this is a little weird, but it's not hard, but you need to have your notes in front of you. Either that or memorize this, and then you'll be good. Okay? I recommend memorization. That's how I remember this, but it's up to you. If A is negative, it rises to the left. And it falls to the right. So something like this. Again, you'll notice the arrow to the left is going up and the arrow to the right is going down. All right? So it's very important. The two things we have to focus on are the degree and the coefficient in front of that degree. Remember, the coefficient means the number in front of the variable. Okay? So you got to first look at the degree, what's the highest power, and then once you find it, look at the number in front of that. And if it's positive, it's going to do something specific. If it's negative, it's going to do something specific. Okay? And that depends on whether your degree is even or odd. All right? So here we go. You guys have the notes. I'm going to kind of move this out of the way. Here's example number 3. All right. So you have 6 problems that are going to look like the following. It's going to say, describe the end behavior. And remember, you want to have your notes right next to you as you do these, okay? We're only going to do 2. They don't take long, guys. Like I tell my classes every year, you don't have to do any math work to do this homework. And there are literally 20. Look, this is the front, okay? Here's the back, graphs. You don't have to do any math. You just got to know the definitions and then write them down, okay? So here's the first one. Let's say we'll do a negative 2x cubed plus 6x squared minus 4x plus 5. And then we'll do part B. Let's say f of x is equal to 6x to the 4th minus 3x squared plus 2. And all you got to do is tell me, what is the graph doing on the left and on the right side? So remember, the 2 things you guys have to focus on first, is it an even or an odd degree? So for part A, is it an even or an odd degree? It's odd, right? Because what's the degree? A 3. The degree is a 3. So that means it's odd. So go to your notes and go to where it says if n is odd. Okay? Then look at the coefficient in front of that degree. What's my coefficient in front of that degree? A negative 2. That means A is negative. So what's my answer? If it's odd degree, negative A term. Rises to the left, falls to the right. So that's all I'm going to do. I'm going to write that down. Okay, I'm going to put rises to the left, falls to the right. And that's it. I don't have to calculate anything. I just got to know the definition. Right? What about part B? What's the degree on it? 4. So that makes it even. Okay? So I'm going to go to the section that says if n is even. Okay? What's my A term in front of that degree? A positive 6. So it's positive. So what's my answer? All right, rises and rises, right? Rises to the left, rises to the right. And that's it. You guys have like 6 questions like that where you're just going to have to look and identify. Okay? All right, so on your homework, let me just kind of show you this. Here are the first 10 that I told you. It just says name the polynomial by degree. So number 1, the highest degree is x to the first. So that's linear, okay? Number 6, 3x squared plus 1. The highest degree is a 2. So that'd be quadratic, okay? We'll do one more just to kind of look. Look at number 9, 5x cubed. A power of 3 is highest. That's cubic, okay? That's how the first 10 problems go. 11 through 14, state the maximum number of turns. Just look at the degree and subtract 1. So number 12, how many turns does number 12 have? Not 3.
4.
4. 5 minus 1, right? Highest degree is 5. Subtract 1, 4, right? How many turns does number 14 have? 1, right? Because the highest degree is 2, so subtract 1, 1. Okay? Easy, right? Numbers 15 through 20, describe the end behavior of each function. So let's look at number, number 18. What's the degree on number 18? 4. That makes it even. What's the coefficient in front of it?
1.
A 1. So it's positive. Even in positive means up and up, right? Up and up. Up to the left, up to the right. What about like number 17? The degree is what?
5.
5 and the A term?
Negative.
Negative. So it's odd and negative, which means rises to the left and it falls to the right. Okay? Again, that's just all in your notes. Okay? All right. So why did I bring this up? Well, because of these. All right. So the last set of homework is going to say sketch. And you guys don't have to write these down. Just kind of bear with me. Maybe I'll do the first 2 for you guys, and I'll just leave them up there while you guys get your homework. Okay? But it says, which one is the general graph? Okay? So let me show you how you do this. It's relatively simple. Okay? Relatively. Not super easy, but relatively. First off, what is that 2 called? You guys remember?
Y-intercept.
That's called my y-intercept. Which one of these graphs, A, B, C, or D, look like they're crossing positive 2 on the y-axis? Which ones look like it?
B and C.
B and C, right? Because notice this one is way down here. That's not a positive 2. So nope, right? This one might be. This one might be. And this one's not even crossing anywhere near. So that's how you start. You look at your y-intercept first. Okay? Then the next way I'm going to try to figure out what's happening is I'm going to ask myself, which way does this behave? Is it up, up, down, down, up, down, up, right? Which way is it? So my highest degree is a 4 with a positive A term. It should go up, up. So which one makes the most sense? B. That's it. You don't have to know what the graph looks like. You're just looking at the behavior. That's it. Okay? So the part C is going down and up, down to the left, up to the right. That's not the behavior of a 4th degree positive coefficient. That's not the way it works. Okay? Let's look at number 2, and then after that, I'll give you guys your homework. So where is it supposed to cross the y-axis? At 1. Okay? All right, so I'm going to go really quick. I'm going to mark to see which ones make sense. I mean, there's that, and that. All right, based on those marks, which ones can't be for sure? I would say A and D, even though there's no markings telling me whether it's 1 or not, but the other ones are lower. That means the A and D have to be higher. That means they might be 2, 3, 4, 5, 6, who knows. So I'm going to get rid of these. Okay? And then I notice it's my degree is a 5, which makes it odd, and my A term is positive. So which way does it behave? So
Down, left, up.
down to the left, up to the right. Down to the left, up to the right. C. Okay? So I'm going to go ahead and stop there and give you guys your homework.